Hi, my name is P. Nitish Kumar and I am currently pursuing my final year of BTech in Electronics and Communication Engineering at Mohan Babu University. I have completed my internship at MTech where I worked on IoT based home automation. This experience, this experiment helped me enhance my technical skills and gain the practical exposure to real world application of IoT and auto, automation technologies. In this internship, I have completed the project on IoT based home automation solution. In this project, explored smart home automation by simulating interconnecting the environment using Arduino Blynk app for focusing and remote controlling integrated essential components. This mainly purpose is to control the things from virtually from the application. We used simulation using the PicsimLab in real time. This project controls the simulating lights, home temperature, and water tank level indicator. This all remote controlled managed by the Blynk IoT mobile application. The main key points of this project is Arduino Uno, PicsimLab interface, and Blynk IoT application for user interface. For controller, we use Arduino, and for the coding purpose, this all things we used PicsimLab. Blynk is used for the user interface controller. IoT. IoT is nothing but Internet of Things, a network interconnected devices communicating and exchanging the data, enhancing automatically enhanced to the smart environment. This object range from commonly home household items like light bulbs and transistors and like that, which we can control the lights or some electronic devices by the from virtually from the app. Is mainly used the devices in cities, infrastructures and traffic lights, environment monitoring. The core idea of every item, digital intelligence allows the communication interference and useful without human interference. IoT is connected to the ecosystem and connected to the cloud which has the data and which we can operating is interface. Here we used Arduino as IoT device as input as light and Arduino for the controller. For the controller in the interface virtually we use Blynk app. Here the Arduino is a platform and enables the development and creativity and interactive projects for collabing hardware and software, making idea choosing choice of the IoT application user friendly environment. Here we used the Arduino. Here we return the logical all the programs for the controlling the devices. We basically written the code in the C programming and C++. Here we used PicsimLab for the writing the code, connecting for the PicsimLab. Here IDE is integrated development environment that runs the computer. We use the write the code and upload the computer code to the physical board. The Arduino board can read inputs like such as sensors, print buttons, or lights like that. So that such that, and the output returns as the active motors, turning the LEDs, pushing the online to the online cloud servers. Because of we use Arduino because of it is simple and flexible, low cost and incredible boosting for the students to enhance their project skills. Simple design and it is more efficient for the low cost devices. IoT home automation solution. It is basically integrating various components and enhancing convincing efficiency and user interference without any problems. We created it. It refers the system where home devices connected internet allows that monitor and control remotely specific solution smart home environment creating using the PicsimLab and IoT Blynk application. This integrates the main feature of garden lights and adjusting the lights depend on the temperature resistance using LDR. The temperature control system is managed by the heater and cooler and water tank management system to control water level and valves that enters the framework demonstrate the complete the IoT loop where the Arduino process sensor data and execute the command sense for the mobile application, creating the intelligence and automated home experience. Here it is the one of the architecture of the project. Here the main component is Arduino controller, which we written the code and consists of the logical program. Blynk cloud is a remote monitor like interface, and sensor is the network data input like LDR, which tells whether sunlight is coming or not. Depend on that, it gives it input to the Arduino. Arduino gives to the Blynk app. Here the one of the project we done garden light control. The garden light control is designed for the simulation automatic adjustment gardens respond availability of the sunlight. The primary input is LDR, which is known as light dependent resistor sensor, which is used to measure the element of the light, which central processing involves the Arduino recording reads the values of LDR sensor. Based on the sensor readings, the system will be varying the brightness of the LED, which simulates the actual garden lights through the final output function. Required the control evolution of the garden lights, which brightness of dims according to the natural light conditions. Defect detect the sensor. Here the main purpose of this project is the Arduino gives the logic and LDR gives the input to the Arduino and Arduino gives the output to the lights. Whenever the sunlight is coming, then the Arduino the LDR sends the data to the Arduino, which the current will automatically decrease to the sending to the lights. Here is the one of the diagram, circuit diagram. The LDR sensor is a light detection for the whether the sunlight is there or not. It tells tells to the Arduino. Arduino is the controller. It sends the data to the output whether the current need to pass or not to the lights. Light is the output. Here the temperature control system. Temperature control system. Here you can see the temperature system and CLCD display, the Arduino and Blynk IoT app. These are the main components. Simulation home temperature management using the heater resistance using LM35 temperature sensor and cooler. The system continuously reading the temperature from the LM35 sensor and display the value both the local CLCD and the Blynk IoT application using the manual control turning on the heater or turning off the cooler, which we can do by the manually also using these dedicated buttons in the Blynk IoT application. The adding the manual control, the system features automatically save the threshold. The temperature reads from the sensor exceed the 35 degrees Celsius. Whether the heat is activated, the system is automatically turn on the heater off. The simulation it sends the notification to the Blynk app and that displays the message on CLCD information using the action. This is one of the diagram. Here the LM35 is sensor as temperature input, heater is heat management and cooler is also cool management, and output we can interface is like we use the Blynk IoT application. Here is the one of the project of this internship, water tank inlet and outlet valve controller. Here in this project we can see the water tank and CLCD display and Arduino Uno controller and Blynk IoT application. Here main the concept is the water tank which is filling automatically need to turn off, or when it is empty it automatically need to send the water. This is the main concept of this. This water tank controller system is designed the management water level reading the volume of the cereal tank and controller. The inlet and outlet valve is system displays the current water volume of the both local CLCD and in the Blynk app. After reading the various serial communication using the manual control over the inlet and outlet valves through the dispensation of the IoT Blynk application, changing the button's logical level prompt to the system that sends the command to the various serial communication through the valves. It need to turn on or turn off. For the future, the system incorporated the automatic controls such as turning as the inlet valve automatically if the water volume drops to 1500 liters. It need to inlet need to on, uh, otherwise it need to close. The inlet valve when the tank is full, the notification automatically sent to the both Blynk app and CLCD. Here the whenever the water is inlet fully coming a full tank, the level of the water 3000 liters need to fill. After that it sends the message to the Blynk app. It is full the tank and it automatically inlet valve will be closed. Whenever the water will be decreased below than 1500 liters, then automatically inlet valve will be turned on. Then only it will be working this logic. We written for this logic. Here is the one of the block diagram. Here is the water management system monitoring the water level and valve controller automatic logic we written. Here is the Blynk interface we taken as inlet outlet valves and heater cooler buttons value how water capacity there and the temperature how much degrees it is there in the room. This is all showcased in the IoT application. Virtually this is designed for the Internet of Things that can control hardware remotely, display the sensor data virtual in the project. The functionally primarily using for the interference with the widgets and creating the buttons in the mobile application management, simulating the home automation system. Button widgets controlled by the heater, cooler, inlet valve, outlet valve. The buttons which will be displayed by the temperature, volume of water in tank, etc. This widgets implemented by and it also displays the notification whether how much the temperature is there, how much is temperature is there. Whenever the water is existed more than 35 degrees, it automatically turn off the heater, and whenever the tank is full, then it also sends the message to the IoT Blynk app. The Blynk app is essential to alert the system safety, providing real-time feedback, enhancing user infinite status update of operation conditions. Here is the serial tank output. This we mainly used virtually PicsimLab environment for the real-time water tank. For in virtually the system interferes the components sending the commands various the real-time current volume of water consist. This volume data sends used to the both monitor control purpose. It displays the CLCD and also in a Blynk IoT application serves input system automatic logic control inlet and outlet valves. Here you can see green color is inlet and outlet is the here downside the output red color is the outlet. In this internship, the outcomes are we learned about the C programming and C++ for the logical writing in Arduino. In hardware, gain the understanding the how Arduino framework simply complex interference allows the rapid prototype. Learned implementing even dive the motor model using the Blynk application functions, written the code executing responsible using actions on app whether the simple line loops. We libraries like Blynk Wi-Fi and using the APIs, building the complex features and cloud connectivity, IoT architecture, understanding the end-to-end flow of the IoT and from the LM35 sensor and controlling from the Arduino cloud platform like Blynk. We use it for and mobile user friendly. We use the Blynk IoT application, simulating and debugging using the PicsimLab and developing and testing this importance of the simulation embedded and using the serial communication and CLCD real-time debugging status of monitoring. This section enhanced my skills and knowledge gained by this internship focus and embedded program and IoT architecture and real-time work program projects. It interfaces between the component smart home, showing how the data flow between the Arduino sensor, Blynk cloud application, and user interface with friendly. Con- Conclusion: this project successfully achieved its goal of simulating a home automation system of leveraging of the Blynk IoT application in conjunction with the Pixing simulation. A key aspect of simulation was the responsible of real-world object using the components like LEDs, lights of LERs, temperature sensor systems, heaters and coolers and serial tank, inlet outlet valves, whether the time water tank and CLCD for the real time, integrating the dashboard for the display, the events, the simulation. Blink the Blink application provides the user interference of remotely monitoring, but we just use it for the control the heater and cooler and inlet and outlet valves in Blink application. We use a virtual display the current control the current temperature and the volume of water. This is the code which we have been used. This is for the IoT application, Blink IoT application for authentication to monitor and control the system. First one is the temperature system. We written the logic for this. When temperature is greater than the 35 degrees, then heater should turn off. And when temperature is less than 28 degrees, actual room temperature, then the heater cooler should turn off. That is the second part of our project. This is for the serial tank. We written the logic. When should turn on, when should turn off. We written the logic for the program. And the notification should come to the Blynk application. The maximum value is 3000 liters. Then it should need turn off inlet valve. Here is the demo. First one is the garden lightning. Here LDR we use. When the resistance high, the light turn off. When the resistance low, then the light turn on. Here you can see when we decreasing, light is closely turn off. When we increasing, it turn on. When sunlight is coming, then it should be turn off. When light is not there, then it should turn on. Here left side, here right side, you can see this application, Blynk IoT, Blynk application. Here you can see temperature. When greater than 35 degrees, then heater should turn off and we should get the notification. Here after 35 degrees, heater turn off automatically. Here you can see in the application. Here you can see in the turn off. Heater is turn off after the 35 degrees. No cooler. Here you can see turn on cooler. Here temperature is decreasing in LCD display. Cutoff temperature is 27.9 degrees. At that point, the temperature, the cooler should turn off and send the notification in the application. Here you can see the in right side application send the notification. And here is the final project of serial tank. Here the water capacity sensor detecting. Here the tank is full, 3000 liters filled watered. Here upside is the inlet. Here you can see right side the application, inlet and outlet. Here you can see whenever I click on the water is outgoing. This is outlet valve. Yeah, whenever it reaches around the 1500 liters below, then it started inlet valve open and sending the water from the inlet. Yeah, here you can see whenever we click on outlet valve off, then it is filling full. After the full, it automatically turn off the inlet valve. The minimum capacity of is 33,000 liters. Minimum value of water need should be 1500 liters. Here you can see it, whenever it fills, it inlet valve is closed. You can see right side automatically cut off. You also can see here note a notification. It is totally automatic. Here now you can see the outlet valve is open. Now inlet valve is closed because of the minimum value should be 1500 liters minimum. After that only. Thanks for giving this opportunity, MTech.